Okay, let's run the simulation. Solid verify. Take a few seconds. Okay, there we have the stock. You can see that area is now nicely closed, plugged. And we run the simulation. Let's run it slowly. Right. You can see that we created a nice counter. And from here, now we can start cutting our port geometry. All right. Let's switch off. Now to cut this port, I'll make slight modifications to the geometry. I'll tell you why. The port machining engine of SolidCAM doesn't like these holes, so I have to close these holes. And I have also to ensure that I give the system single tubes as much as possible. So we're going to do some small geometric modification, but we're not going to change any geometry as such. Okay, let me edit the part, and I will offset the surface. So basically I'm going to create a copy by making an offset of 0 millimeter. That's 1, 2, 3, 4, and the fifth one up here. So those are the geometries that we are going to modify. Basically we are going to close certain areas, that's it. So I'm going to switch off and only show the geometry out here. So these are the two holes now we're going to close. What we're going to do now is we'll untrim the surface and we'll fix only the internal edges of these two surfaces. Okay. Also, let's go to the surface, untrim this one. Okay. Right. So we also had some issue with that surface. We did that. Okay. The first part is done. Very simple. I have a plane with me out here. This plane, I'm going to just split the surface into two halves to ensure that I get single tubes. So I'll use the curve split line. I'll pick the geometry that I need to split into two. That's it. And using a 3D sketch, I'll just create a simple line. Start and end at those 2 points. Perfect. That's done. We'll now create a filled surface between those 3 edges. So what we have now is one tube, the second tube, and the third major tube. So we have made distinct changes in such a way that I'm getting visibly 3 different tubes. All right, let's come out of our editing mode. I won't switch on that entire model just to make it easy for me to program it. I'll go to my tool library because I already have this tool made somewhere else for another part, so I'm going to import that particular tool. Okay, it's going to be a CAM part. We're going to have it in another folder altogether. Okay, SolidCAM, webinars. Okay, set parts, port. Okay, so I've got a port. I've got maybe another one of this one. Okay, yeah, this one, 16 millimeter lollipop tool. Now if I look at the tool, this is how the tool looks like. That's out of the holder and the holder itself. So we're going to use this tool. I'm going to import all of that. So I've got the tool back in my library. And as far as the holder is concerned, I'm not going to use the BT40 because my machine is an HSK machine. So I will use the HSK holder. Okay. Right, we are now set to start our port machine. Now you can look at how easy this thing is going to be. Right click, add port machining. We have got 4 options: roughing, rest roughing, spiral finishing, and plunge finishing. We will use the roughing to start with. The geometry to be cut, simple, machining surface, 1, 2, 3. That's my first tube that I made. Now you realize why I created that surface by splitting the geometry. So this becomes 1 port for me. I'm going to say OK. The tool, in this case, is going to be a 16mm lollipop cutter. Levels, it's parallel to, I want to have a cylinder that's parallel to x-axis, so that when it retracts, it should retract around that cylinder. So it's going to be around x, and the center is somewhere out on this point. That's where the center of my cylinder is. I'll need a retract of 75mm and an entry distance where I need my feet down by about 10mm. Okay, I don't need anything else. Go to the toolpath parameters. Step over is going to be 5mm, and step down is going to be 2mm. My tolerance, since I'm roughing, I'm going to keep it at about 0.1. Sorting. Now, because we are machining only 1 tube at a time, I have an option to machine both the tubes at the same time. In such case, the software will always travel down to the midpoint of both of the upper tube and the lower tube and merge both the tool paths. But since I'm going to do only from one side, I can select the top side, and I can tell SolidCAM to go maximum from top side, as much as you can. That's fine. The direction for machining is climb with a ramp angle of 5 degrees. So it's going to ramp every level. Tool axis control, you can see that there is absolutely nothing. Everything is defined automatically inside SolidCAM. Link, nothing. Gouge check, we're going to check against the machining surface, the surface that we have defined for machining. Clearance is not there since we have not defined any gouge check. That's it. Let's hit save and calculate. Okay. Let's click show, and you can see that the software has already calculated the toolpath with a nice tilting. So see how it looks like. Let's take it to our Solid Verify. So that was the first process. It's already updated in my stock. Let me run the simulation. I don't have to define the gouge check. I don't have to define tool axis control. Everything is done automatically by SolidCAM. It picks everything by itself and does a very neat job. However, in event that you still have gouges, in our case we're going to have one because of the holder. We will see how we can easily correct this. Let's increase the speed. It's going tantalizingly close to the upper surface that's already machined, and in event it'll dig, this is what I get. It's telling me that there's a holder and the machine stock has crashed, obviously, because you can see that the holder is already touched. Now this is pretty dangerous, so we are going to stop this. Come out of the calculation, and I'm going to switch on the entire holding the port geometry, not just only the ports, the entire engine. And I'll go to the gouge check, and I'll switch on the check surface, and I'll define this surface to be checked for gouging. And the clearance now comes into play because we have defined the gouge surface. So against the holder, I need about 5 millimeter. So it should stop if it's coming close to 5 millimeters. Anything below 5 and below 5, it will not. It'll just stop the toolpath. Okay, another thing that we need to do here is to give an offset, which I forgot. I need a 0.5 millimeter offset for my next finishing operation. Let's hit save and calculate. Okay, that's done. The calculations are pretty quick. So we can even take a nice section out here and look at how the toolpath looks like. You can see that it's gone. Earlier it was going much below, now it's stopped up. And that's the reason why we have the toolpath stopping. That's because of the gouge check. The principle of working with port machining in SolidCAM is it tries, in roughing, it tries to do as much as 3-axis roughing as possible. A point comes when it no longer can do 3-axis, and then it starts tilting the tool. So it's very smart in handling these kind of geometries. That's it. No gouges, and it's machined as much as it can with the given set of tool geometry and the gouge check conditions that we have given. All right, let's repeat the same on the other side. So I'm going to switch off again that one. And let's save and copy. And in the geometry, I'm going to define 1, 2, and this common surface, 3. Okay. The gouge check still remains because we still are doing the top side. And let's hit save and calculate. Nothing. I just changed the surface. I'm calculating it. The results are almost instantaneous. Again, it's done all the hard work of doing the tilting, checking for gouges, and we should have a much cleaner sorry. Let's come out of this and let's run the machine simulation. What I will do is we'll also calculate for the other side and then run the machine simulation straight away. Okay, so I'm going to again, that's because this was not calculated. Okay, now we can run both of them together. Solid verify. Okay, let's run the calculation and now the simulation. See, there's a question. It would be nice if we can put the question in the chat so that I can answer you rather than raising up your hand. I think it's Andrew Luther. If you could just put your question in the chat area, it'll be nice. Thank you. Okay, the first port is done. We're going to the second one. So we have completed 2 of them, and now what remains is the front one. So let's do that. I'm actually again going to copy this operation and paste it because most of the things are same except for a couple of things, because now we're going to do it from the bottom. So I'm going to edit, change the machining surface. We've got 1, 2, 3, and 4, and 5. So these are the surfaces that will be used. You can even see how the surfaces are. They're not very nice, but this is how the geometry has come to us. Okay, so let's accept this geometry, and I'm going to switch on again the imported port. And the only thing now we're going to do is in the gouge check, I'm going to switch on this surface as my gouge check because that's from where we're going to machine. So I don't want the holder to touch. Obviously, in the toolpath parameters, we're not going to machine now from the top, but we're going to machine from the bottom, and we're going to go maximum from the bottom. That's it. Let's hit save and calculate. Question Andrew asked was, why did I divide these port surfaces into 3 distinct areas? The main reason being in SolidCAM, we currently cannot handle more than 1 tube at a time, and that was the reason I split it. The second important reason being, even if we had something close to a single one, we made it less complex for the system to handle. You can see that's the reason why the calculations are much faster. They're much faster. But the main reason is currently we don't still support multiple tubes at a time. We do 1 single tube at a time. Okay, that's this toolpath. Let's run again the section view, and you can see the machining from this side. Let's come out. Let's run again now the simulation. The solid verify. We've machined these 2 sides. Now we have to cut from this side, so I'm going to run that. Okay, let's open the question panel. Sorry, we're going to do the finishing operation now. And in finishing, we have got 2 options. One is spiral, and the other one is along. Spiral is a more common way of cutting, but in some cases, the customers are very particular about the flow direction of the gases. So your finishing must follow the direction of the gases. In such cases, you can't use spiral because the spiral will produce a scallop which can obstruct these gases, and thereby your performance of the engine goes down. In such cases, we can use what we call as a plunge finishing. So on one tube, I'm going to show you spiral, and on the other tube, I'm going to show you plunge finishing. Okay, there's another question. Just a moment. port machining. Yes, the port machining will only work on tubes because this is a specific module. It's meant only for such geometries. If I mean, it need not be a tube, but what I'm trying to say is it is meant for such geometries where you have got a round cross section or even a squarish cross section finishing out as a round, but it has to be similar to these geometries because this function has been specifically written for such application. It can't handle, for example, you can't take a port machining and start to do something else. It will not give you a result. It will produce a lot of errors. So it's meant only for these. If you want to do something else, then we have got the 5-axis module of SolidCAM, which can handle any geometries, any kind of application. This has been written specifically to make the programmer's life easy and create very accurate and smooth toolpaths. Okay, so what we're going to do now is we're going to add port machining, and we're going to use spiral finishing. And in spiral finishing, I want to do the first one, which is the faces, which are these faces. I want to do the first one using spiral, and the tool I'm going to use, I'm going to copy this tool and change the length to 115 out of folder, so I have got a much bigger length. Select levels, again parallel to X. This is my point. Okay, let me switch off again the entire port and select one point out here. That's going to be my center of my cylinder, along which I'll have all my retracts, 10 mm. Toolpath parameters, maximum step down of 1 mm, tolerance of 10 microns. Again, I'm going to go from top, maximum from top. And we're going to have climb machining in the entire spiraling operation. All right, gout check. Again, we will select the gout check. In this case will be against faces 1 because that was the face that was used for setting up gout checks for the top side. So it's faces 1. Okay, let's run the calculation. The question was, can we use end mills? The answer is no. We use only lollipop type cutters, and the reason being the amount of tilting that happens when you're doing port doesn't really suit the geometry of an end mill, and that is one of the reasons why we don't use end mills in port machining. And even in general, if you go to many machine tool people, for example, there's a company in the United States that specializes in port machining machines called Centroid, and you can see most of their machines use the lollipop cutters for doing roughing as well as finishing. Okay, so let's look at the result of the spiral finishing. That's nicely done. It starts and goes as much as it can. Now the next geometry that we're going to see is we are going to use the plunge finishing. So I'm going to, in fact I can just copy this, paste, edit this operation and go for plunge finishing. Geometry, I'm going to use faces 2, that's the second one. Tool is the same, levels the same because we are not changing anything. Toolpath parameters, a maximum step of 1 millimeter. Sorting, top maximum from top. Tool access control default. Link default. Gouge check, the check surface in this case is faces 1. Okay, let's save and calculate this toolpath. Okay, the calculation is done. Let's look how the finishing looks like. You can see if I put it in wireframe and if I change the background to rooftop, that's how my finishing looks like. It's running along, the toolpaths are running around along the flow of the gases. So we have got both the types of finishing. We have got the spiral finishing as well as the plunge finishing. So these two are done. Let's again copy the first one and finish the main one. So I'm going to copy this operation and paste it. Edit. Obviously, we're going to use a different geometry in this case. We're going to use faces 3. And this tool is the same. Levels the same. Of course, we're going to use spiral finishing here. Faces 3, 0. Let's select, change the tool. Toolpath parameters, 1 millimeter. The sorting, bottom, maximum from bottom. And in the gouge check, obviously we're going to use the surface that was selected for faces 3, and that's faces 4. You can also name this faces for much easier identification. Okay, clearance area. Okay, that's done. Let's save this and calculate it. Okay, that also is done. We've done the machining now for the main side, and now what I'm going to do is I'm going to set all of that to simulate on a machine. So we're going to move this to the machine. Obviously we have some issues which I did not take into consideration. We need to do some setup to push the part, because we have a part which has got a height, so it has to be above the bed by a certain height. So what is the height of this part? This is about 125 millimeters, plus I have got another fixture below of 100 millimeter. So I'm going to set a setup height here of 225 millimeters in Z. This will push the part 225 millimeters from this point upwards so that we get a proper simulation. Let's run the machine simulation. I have the structure of the machine. Obviously, I've switched off the guard. It's basically a Hermle C30. And in the access control, I can actually use the access, because the doors have also been defined as an axis. So we can use that and push the door apart. But the best thing is to switch off the guard and show the simulation without the guard. These movements are probably the reason why we don't recommend usage of end mills, because the amount of tilt you're going to have is tremendous as it starts approaching inside, and the only cutter that is probably capable of handling these tilts and the swings is only a ball nose kind of a cutter. You have got a spherical type of a surface that can maneuver itself all the way down. Okay, that will continue. Can increase the speed. So I also would like to know how the plunge one looks like. That's how the plunge looks like. All right. So what we have seen today is taking up port, splitting up into simple 3 different ports, and then machining all of them using the specially designed module of SolidCAM for port machining. If you'd like to see some of the outputs, generate a G code straight away. Okay, this is for Heidenhain. This is a continuous continuous G code for Heidenhain. Then we have got the positional one for Heidenhain. Okay, then you have the angle, basically to which the table will tilt, hold itself, and the machining starts. This particular webinar of ours will be available as a recorded webinar on our website, probably another day. It will go up on the website, and you can look at the webinar if you have questions. If you want some of us to come and show it to you at your own works, we'll be more than open. You can just write down to us, and our rep will get in touch with you to take this further. If there are any questions, you can again put it in the chat area, and if there are questions that are going to come later on, you could write to me. I can put down my email address to everyone. That's my email address. So you can write to me if there are any questions. If there are no questions, we will end this webinar, and we will meet you again probably in another week's time with something much more interesting coming out from the stable of SolidCAM in 5-axis. Of course, there's a question again. Somebody has raised their hand. Yes, Mr. Pawan, you have a question. Could you put it on the chat area, please? If you can put it in the chat area, you could put it in the chat area. Else, you could write to me. You have my email address, and we will answer you once I have seen the question. Can we finish this in 3-axis? Honestly, we can finish in 3-axis, but it's going to take much more time, much more effort, which is actually not worth it, because you're going to run into several calculations. Because first thing you need to decide is which is going to be your best orientation to orient yourself and then do the 3-axis finishing. So getting to that orientation itself is going to be a major headache. But when you have something that's already there, which can take care of your programming needs, I don't see a reason why we need to go back onto 3-axis to do the sport. Probably the sport is a bit easy. There are ports that really cannot be approached by 3-axis. You have to use 5-axis in such cases. But to your question, whether this can be done in 3-axis, yes, it can be done. You'll need few settings. You need to have different indexes to get to each of the surface. But then the biggest problem is sacrificing the surface quality, because if you have more number of setups, you're obviously going to sacrifice the surface quality. And the reason why you're machining the port is only to get surface quality. If there are no further questions, we will close the webinar. But again, like I said, if you have questions, just feel free to write to me, and I'll answer as much as I can. If not, somebody from your area will come and answer that question for you. Thank you very much, and have a nice day.